Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at differentiation and we are doing example 5, which is the last example when we are using method 1, that is dealing with powers and coefficients. Example 5 says differentiate the following functions. Part A says we are given y equals to 3x power 6 plus 1 out of 4 x cubed minus x. So we need to differentiate y with respect to x. Y is the function, x is the variable. So we shall say differentiating y with respect to x, dy dx equals to, we say 3 times the power of x, which is 6. Then we say x, now we need a new power of x, which is 6 minus 1. We have differentiated the first term, and then plus the second term is 1 out of 4 times, we lower the power of x, which is 3. Then we say x, now we need a new power of x, which becomes 3 minus 1. And then minus, this x here has a power of 1. So when we lower 1, we shall have 1 times 1. Because here there is an original 1. Then we attach x to power 1 minus 1. So on simplifying this now, we shall have 18 x power 5 plus 3 out of 4 x power 2 minus 1 times 1 is 1. X power 1 minus 1 is the same as x power 0. And x power 0 is 1. 1 times 1 is also 1. So this is the answer for part A. Going to part B. Part B has given us y equals to 20 x cubed minus 1 out of 4 x power 4. What do we do here? We are going to say differentiating y with respect to x will give us, we shall have 20 times 3. We shall have x power 3 minus 1. Okay? And then minus 1 out of 4 times, we lower 4 times 4. And then you have x. Now the new power becomes 4 minus 1. Then we simplify. That gives us, therefore, dy dx in part B becomes, this is 60 x squared, 60 x squared. And then with 4 and 4, it gives us 1. 1 times 1 is 1. So minus 1x, which is the same as x power 3. So this is the derivative of the function in part B. Now let us go to part C. Part C is a function s, given s as 1 out of 4 t power 3 minus 3 t squared plus 5 out of 2 t. Please, this is t. It was my mistake in copying. Please, this is t. Yes. So from here, what do? We say differentiating s, so we shall have ds dt, because we are differentiating function s with respect to t. T is the variable in the expression or in the function. This gives us here, we are going to have 1 out of 4 times the power of t, which is the lower, so times 3. Now we shall have new t. Now the new power becomes 3 minus 1. And then we continue, say minus, we have 3 times, what is the power of t? 3, sorry, 2. The power of t there is 2. So 3 times 2, t. Now the new power becomes the whole power minus 1. And then plus 5 out of 2 times, what is the power of t here? It is 1. So times 1. Then t, 1 minus 1 for us to get the new power. Then we simplify. This gives us here 3 out of 4 t squared minus 6t plus 5 out of 2, because t power 1 minus 1 is 0. T to power 0 is 1. So 5 out of 2 times 1 is 3. 5 out of 2. So that is the solution for part C. This is the derivative of the function of S. Now, part D, this is D. Part D, we are given y equals to x into 5x plus 3, and then plus 4 into x plus 1 squared. And that we need to differentiate that given function. Now, what we can do here, the first step is to open the brackets and expand. So let us first expand. So this is still y. We're just expanding the function of y. That means x times 5x gives us a 5x squared. X times 3 gives us 3x. We have expanded that side. Plus 4. Now let me first square x plus 1. Okay? If we're squaring x plus 1, it means it is x plus 1 times itself. Let me put a square bracket. It's the same as x plus 1 times x plus 1. Now, what do we do? Let me keep this side plus 3x plus 4 into. Let us expand x plus 1 times x plus 1. This gives us here x squared, because x times x is x squared. X times 1 is x. Now the time is 1. 1 times x is x. 1 times 1 is 1 plus 1. This here gives us 5x squared plus 3x plus 4 times x squared is 4x squared. Inside here we shall have x plus x. These are right terms. X plus x is 2x. 2x times 4, it is 8x. 2x times 4 is 8x. And then plus 4 times 1 is 4. Then we collect the like terms. Here we have a term x squared and term x squared. So 5x squared plus 4x squared, it gives us 9x squared. And then we have 3x plus 8x, it gives us 11x. And then plus 4, which is there. So this is, therefore, this is just y. We have expanded and then combined the two terms that were given in the function of y. Now we need to differentiate y. Therefore, differentiating y with respect to x, dy dx becomes 9 times 2 x power 2 minus 1 plus 11 times 1 or x 1 minus 1, because this is the power 1. And then plus, if you differentiate 4 is a constant, it gives us 0. That means we shall have 18x power 1 plus 11x power 0 plus 0. This now gives us 18x plus 11. So this is the derivative of the function in part D. And this is the overall solution to example 5, which is the last example that we are doing under operating powers and coefficients to find the derivative of a given function.